Assalamu alaikum wa rahmatullahi wa barakatuh. Environmental management system, life cycle perspective. How do we identify environmental aspects and how do we manage environmental aspects with life cycle perspective? Come back to that. Thank you, YouTube. Thank you, all subscribers, viewers, and supporters of this channel. I'm grateful. I'm honored to have you here, and for me, I'm honored to be able to address you on all these environmental issues, environmental topics. Now, in this video, we are going to look at the life cycle perspective as stipulated under ISO 14001 version 2015. It is a very useful knowledge. It is useful in the identification of environmental impact for all our respective environmental aspects. Okay, and in this video we're going to look into metal ingots, take a look at its life cycle. Okay, and when we view that, we are viewing metal ingots from life cycle perspective. With that knowledge enables us to come up with operational procedures how to manage these environmental resources. Okay, let's take a look at the next slide. Now, let us recap environmental management system definition as per stipulated by ISO 14001. The environmental management system is about managing what? Environmental aspects. How do we manage it? Fulfilling compliance obligation and addressing risk and opportunities. That is the definition of environmental management system. So we got to manage environmental aspects. How? By setting operational procedures onto processes in a way, in a manner, in a setting that all the environmental aspects that is involved as input into the system and also output being released out of the system, and also the system consists of machines. In all these are environmental aspects. We have to look into how to manage them in order to reduce, if not eliminate, all probable environmental impact that is probably the consequence of that particular process due to the presence of those respective environmental aspects. Okay, that's clear. Now, by far, this is the best definition of environmental aspect given out by ISO 14001 TC207. Wonderful job. They've done a marvelous job by having such a definition. Now, what is environmental aspects? It is the element of an organization's activity. What are our activities? Production processes, perhaps. Transportation, perhaps. Power generation, perhaps. Smelting of metals, perhaps. In this case, perhaps going to discuss that a little bit. Okay, and producing products. And products are environmental aspects. And our services. What are our services? Probably aircon servicing, for instance. So the tools that we carry to the aircon service are environmental aspects. The aircon unit is environmental aspects. The filter for the aircon is environmental aspects. The aircon system, those compressors, those blowers, those inverters, they are all environmental aspects. Why? Because of this. They interact or can interact with the environment. Simple as that. Okay? Anything. The word is anything. Could be a matter. Okay? Could be a substance. Could be material in the form of a machine, in the form of the components of the machines, in the form of the raw mats that the machine uses, probably lube oil, probably hydraulic oil, or probably some raw mats that they got to process. And from that process, generate product. Those products are environmental aspects, and perhaps generate residues or intermediate products. Those are all environmental aspects because they interact and can interact with the environment. I hope that is clear. So that is the definition of environmental aspects. Now let's take a look into the next slide, why we need to know life cycle perspective. I'm giving you a holistic, an overview picture when we do life cycle assessment, but we're not going to do life cycle assessment, because if we do life cycle assessment, we have to have allocation and boundaries. All right, now in this case, this is an example of a product life cycle. What product is that? This is the product. For example, what is it? A car body, not the whole car. The product here for this particular factory is assembling, grinding, welding to make a car body. All right, now that is the product. Now, is this an environmental aspect? Why? Yes. Why? It interacts with the environment. How do we know that? By looking at its life cycle perspective. Watch out. If we go upstream, there you are, the word is upstream, of the life cycle of this car. In other words, we look where it comes from. Of course, this car comes from an assembly plant, putting together all the car parts and components into what you see now. But those are made of metals. It comes from metal fabricators. So there is an array of a lot of factories involved around here. So I just cut it short. Okay. Eventually, all these processes which form the body parts, bending, metal, stamping, you name it. Okay. Eventually, it goes back to the simple basic product, which is metal sheets. And where does metal sheets come from? Steel mill. And what are the raw materials for steel mill? Metal ingots. They've got furnace, right? And what are the raw materials before they produce the ingots? This is the one. What do you call this? Metal ore. That is the upstream of the life cycle perspective of this particular vehicle body alone, not a complete vehicle. I'm talking about one allocation, which is the metal part. All right. Well, that's if you do life cycle assessment. Now, this metal ore is coming from mining. What is mining? It is the excavation, it is the retrieve, it is the extraction of metal resources from rock structures of which is embedded in the earth crust or in the earth geological structures. Put it simple. The more demand for this car frame, the more demand at this point, I'm not talking about the more demand for cars, that will be downstream, all right? This point, the more demand for this particular product means the more demand for metal ore. And metal ore, well, I don't keep the inventory of the resources, but you could ask experts. Metal ore is coming from natural resources, rock structure, geological structure, strong geological structure. It has been mined, it has been exploded by explosion, all right, by drilling into shaft, etc. All sorts of methods in the extraction of all this metal ore. And then the environmental impact to that is actually very popular. You know this best, resource depletion. But if you ask me, I'm more interested in the damage that we have caused the environmental resources. What? Damaged geological structure. I'm more concerned about that because that damage would, well, make the mesosphere of our Earth more unstable. The plate tectonic, remember? It is not stable and we make it more unstable by all this. Well, that would be the upstream environmental impacts for the aspect car frame under discussion. Now, what happens next? Then it becomes a car. So I draw a line here. This is the border. I call it at this point of the life cycle stage. I draw a line because there is a lot more downstream processes until you get this so-called metal debris. Now, metal can be recycled many times. Ask, please consult the metallurgist. They are the experts, but they have got to, convert into alloy. They got to do a lot of mixing, but eventually that particular iron upon time has lost metal strength, it becomes brittle and no longer recyclable. As far as I know, please correct me if I'm wrong, okay? And at that point, these will be metal waste. It gets rusted, it just gets into dust, like soil dust, okay? And it cannot be recycled anymore. It looks like dross, okay? And that in many countries, especially where I'm from, is regarded as scheduled waste because it has got metallic contents and a lot of other metals other than iron. Okay, so that will be where what happened to it? It will be disposed of. Where? Probably landfill. Okay, and what happened? It will cause perhaps at least soil pollution, if not groundwater pollution. There you are. Okay, and that is the end of the life cycle of this structure called car frame when we look at its life cycle. So we're looking at its life cycle perspective, and in between here these are all recycling, and this recycling work amount to what we call resource conservation because they are recycling those metals in between that, all right? And that is good for the environment. The more recycling, the less demand. Well, I wouldn't say the less demand because human population is increasing, infrastructure development is increasing, more highways, more cars. Well, we can slow down the rate of resource depletion. So we call it an environmental impact forest resource conservation when we do recycling. So that is how we got to know the life cycle perspective of this particular car frame, and we have identified by using life cycle perspective, we know this car frame, where is it in the life cycle of that, product, which is a car frame, and we can look upstream to determine the impact, and we can look downstream of its life cycle to determine the environmental or the associated probable environmental impact. That's our discussion. Now, I hope this is clear. This is my attempt to display to you the environmental aspects as you could see in the bluish green fonts on top of the slide, and it will be followed by some red fonts at the bottom of the slides. These are all environmental aspects. This is the early lessons, probably introductory elementary lessons when you do, I believe, mechanical engineering, when you take up process engineering, which amounts to mass balance. But we're not going to do mass balance. I'm not a mechanical engineer myself. I was a microbiologist, now ending up in environmental sciences. Now, I got to study a little bit of mechanical engineering from my gurus, okay? And this is what I'm displaying. Look, all the resources that we have up here are coming from natural resources. We would call it environmental resources. We take fuel, for example, from fossil fuel, and we make diesel, petrol, and we get lubricants out of it, etc., etc. All right, and it gets into all this. Sorry, this is actually already an output. I should begin from the bottom. Okay, these are all the. All right, they're making lubricant into production, and it gets into products. There you are. These are outputs. Okay, from fossil fuel you make products, of course it goes through production. Okay, and you get waste byproducts as output. These are all input. Metals are from natural resources, chemicals are from natural resources, minings, etc., and turns into fabric and electrical energy coming from coal, perhaps. So these are all environmental aspects input. So it is going through production somewhere around here and is being used by us. And after use, which is at the end of its downstream life cycle, it becomes probably solid waste. It becomes air pollutants, and probably it becomes hazardous waste like scheduled waste in this country, or industrial effluent, or other kinds of effluent, and perhaps reject materials which can be, well, recycled. Now, those are environmental resources. The is not that greenish, it is yellow, representing that these resources are being tapped. It has been tampered with. I'm not good at drawing. This is the best I could display a single dimension, perhaps, and this is what we have. The environment is actually being tampered with. Mostly from the extraction of resources, and it becomes unstable. Resources are depleting. There's a lot of ecological imbalance or disbalance, how you put it. The TCA cycle, Krebs cycle, hydrological cycle, nitrogen cycle, sulfur cycles, and all these are being disrupted. So we have problem there. And when we get products for our quality of lives, we produce products and at the same time we produce all these waste at the same time, and some of it, in fact almost all of it, are being embedded back, returned into the environment in a form which the environment do not recognize. We get iron ore in this discussion from the environmental resource up here, metals, but we end up releasing metals which is contaminated with chemicals, or even metals in a form of dross, which the environment might not be able to comprehend. And that will take time, and that causes environmental impact, namely soil contamination. So these are the various environmental impacts downstream for environmental aspects. And what I have upstream are, due to the extraction of these resources, we have got hydrological disbalance because some countries extract water from groundwater. Resource depletion is another environmental impact. Geological damage is another environmental impact due to the extraction of all of these resources. And of course, in many processes, causes releases of air, causing adverse climate change due to when we extract resources, we are cracking the bedrock structure. Water, which is supposed to cool the Earth's surface, is no longer there because they are deviated due to cracks in the bedrock structure, etc. Ask geologists. Refer to them. I just learned from them. All right. So this is the basic idea of the life cycle perspective, from environmental resource to human tampering, human make, human processes, human activities, human consumption, and then down back it is disposed of into the environmental resource again, into the environmental ecological system, but not from the same place, elsewhere, usually. Okay, I hope that is short and sassy. Let's take a look At one example, let's find out what are the what do you call what is the life cycle of metal ingots in this case. I think you know. Metal ingots are excavated from earth resources, rock structures. You take gold from rocks, you take uranium from rocks, you take what? Thorium, palladium, name it. Copper, lead, zinc are all from rock structures. Okay, now this is the entire life cycle of one environmental aspect in discussion, which is metal ingots. This is rather upstream. Okay, metal ingots. It is. We're not talking about car body over here. We shift to metal ingots to determine what are the impacts to environment when we want to produce metal ingot. Take a look. It comes from metallurgical industry, of course. There are a few, one or two more industries. I can lump them together as metal-based industries, and eventually they get raw mat, which is iron ore. There you are. This is iron ore. How do they get it? Mining. What do they mine? The rock structure of the earth crust, of the earth surface. So now, as we are discussing, we are looking upstream of the life cycle perspective of metal ingots and the environmental impact upstream for the environmental aspect metal ingots is resource depletion. And I would also add geological damage. There you are. Got it? So this is the life cycle perspective of metal ingots, which may be an input to this metal-based industry. So when we are doing the ISO 14001 for this metal-based industry, and one of the environmental aspects is metal ingots, then the associated environmental impact to that metal ingots is resource depletion and geological damage, as you could see. That is how it works. Okay, and of course, from the metal-based industry, you got metal products. I stopped the life cycle assessment or life cycle perspective over there. I draw a border there, and metal products gets recycled. And there is a plus point: when we recycle metal, we do not pollute the environment by disposing into soil. Okay, for that matter, except for residues, which can be recycled also. And when we are able to recycle metal products, the demand for metal-based industry product for metal ingots is less or stalled. So at least we can slow down, retard, or, well, we won't eliminate the fact that the environmental aspect that can occur, such as resource depletion, by doing recycling. So that's how it works. So this is one environmental life cycle perspective. If you got to do ISO 14001 version 2015 and identifying the respective environmental impact for your environmental aspect. So the metal products over here is that car body as we saw just now. But in this part, we are looking at the environmental aspect metal ingots. So the associated environmental impact for the aspect environmental ingot is resource depletion and geological damage. Can we control? No. Can we influence? Yes. Process? Maybe not, but procurement. We need to have procurement to select materials, higher purity materials that we can recycle in the industry itself. And when it has got to come to the end of the life cycle of that vehicle, we can get the vehicle to be returned back to our industry for reprocessing, recycling. Well, at least where I'm from, it's not working that way yet. But I believe Scandinavian nations and in the States, perhaps, correct me if I'm wrong, they are already doing this, which is remarkable. Hopefully, one of these days, the policymakers from where I'm from would see this and would look at this as another source of job creation. Recycling is creating jobs. Okay, so. What I have in the next coming video is a detail, and well, I would say detail, but I'm not addressing all the environmental aspects. We are going to look at the input-output analysis, a methodology that is used to identify environmental aspects, as you already know, and how we identify in practice environmental impact for those respective environmental aspects. Hope to see you there. Thank you, YouTube. As a Malaysian, I wish everybody semoga dikurniakan kesenangan, keselamatan, kesejahteraan, kebahagiaan, dan kejayaan kehidupan di dunia dan di akhirat. Get somebody to translate it. If you want, give a comment. I'll translate for you. And until we meet in the next video, thank you for your attention. Love all of you. And I wish everybody, wherever you are, all the best in good health and prosperity. All right. So until we meet in the next video, I wish everyone Assalamu alaikum wa rahmatullahi wa barakatuh.